Oh, okay, so hello, my name's Samuel, and I'm gonna be going over meteorology. Yeah, so I've done meteorology for around, I think, 3 years. In Division B, I did with Andrew. I think for 2 of those years, yeah, I think we did quite well. So, is it about the weather? Yes, it is. Okay, so let's begin. So first, what is meteorology? Meteorology is the branch of science focused on the phenomena in our weather, such as we have daily weather changes, we have severe weather like thunderstorms, hurricanes, tornadoes, and we also have like more large scale effects such as climate change. Uh, so in Science Olympiad, this event cycles between three main topics: climate, everyday weather, and severe storms. Over here on the right, you can see like a graph, I guess, of the topics, the cycle. And yeah, so last year, uh, I guess, yeah, last year it was everyday weather. I did it in the years 2020, 2022. So I did severe storms twice and climate once. And this presentation will mainly focus on severe storms because, as you can see, I have 2 years of experience on it. So if we look over the rules, you can see this rule sheet. I think this was probably from 2021 or 2020. And these are like pretty standard rules. It's only a study event. And this like category, I don't know, like number 3, you'll see all the topics. And yeah, so one big difference from this and Dynamic Planet is is that um is that this event uses a cheat sheet rather than a binder. So you only get 2 sheets of information. That means you have to write quite small to fit as much information as you can. So despite there being like numerous different topics, there are many like basics you should know about the atmosphere. For example, we have the atmosphere composition, such as like the chemistry in the atmosphere. We have atmospheric circulation, energy balance. We want to know the tools to measure these um, atmospheric phenomena or meteorological phenomena. And one important thing is we want to know the impact on the society. So first, let's go over atmospheric composition. The atmosphere is like defined, its definition is the layer of gases that surrounds the Earth. Um, Earth's atmosphere is composed of, we have 78% nitrogen, 21% oxygen, and then we have what are called like trace gases. These are like argon, carbon dioxide, and they all make up that one last percentage. And we also have water, or like water in our atmosphere, and the amount of water, it normally like varies throughout, right? In drier areas, we probably expect a lower percentage, while in, I guess, like more humid areas, we'll probably see a higher proportion of water. And the atmosphere has 5 main layers, as you can see on the right. We have the lowest one, which is the troposphere. We mainly focus on this because that's where most of the weather occurs. We have the stratosphere, mesosphere, thermosphere, exosphere. And in the stratosphere is that weather balloons. Yeah, weather balloons, they usually like go upwards, like up into the air, so they can measure different properties of the atmosphere. Next, let's go over atmospheric circulation. So atmospheric circulation is the large scale movement of air, and this is caused by Earth's rotation and its like uneven distribution of heat. So over on this right, we can see like the three main cells, which are like these, I don't know what shape this is, but like, I guess if you look at it from the side, they kind of look like a triangle. So from 30 degrees to, or zero, like 0 degrees to equator to 30 degrees, either north or south, we have what are called Hadley cells, that you can see here. Um, and then from 30 degrees to 60 degrees, we have the Ferrel cells. And then 60 degrees to 70 degrees, we have our polar cells. And yeah, I guess one interesting thing is, you notice like they're kind of alternating the direction the air flows. And generally, wind direction changes with location, height, and seasons. Over here, we can see these are like these colorful belts. These are called the global wind belts, and these are relatively like permanent directions that the wind travels in these belts. I won't go too much in depth, but you can see the arrows signify the wind direction. Now let's look at clouds. So clouds are masses of tiny water droplets or ice crystals, or even like dust or other aerosols. And these are suspended in the air. Clouds are formed by condensation, which is part of the water cycle, as I'm sure many of you guys know. And to classify clouds, we look at their shape, look at their thickness, and sometimes their altitude level. So first we have the low level clouds. These are found generally under 6,500 feet in the air. And some types we have are cumulus clouds. Cumulus, they generally mean fluffy, and they usually signify stable weather. We have stratus clouds. These are layered gray clouds, and there's not much precipitation. We have stratocumulus, which is a combination of stratus and cumulus. And these are dark like stratus, but they're also round like the cumulus. And lastly, we have nimbus clouds. Nimbus means rainstorm, and it's a Latin or Greek, I'm not sure. Yeah, so in this background, you can see um, cumulus clouds. You can see they're quite fluffy. Next, we have the middle level clouds. These are found in altitudes between 6,500 feet and 2,300 feet. These have the prefix alto, which means high. They're generally pretty high up in the air. The main types we have are altostratus. Similar to stratus, these are relatively thin and layered. There's little precipitation. And we have altocumulus, which are more patchy and like, yeah, more fluffy again. And in the background, you can see altostratus clouds. Yeah. Next, we have high level clouds. These are found at altitudes above 2,300 or 23,000 feet. And these have the prefix cirro, meaning wisps in Latin, I think. So the main types we have are cirrus. These are like thin wisps of cloud. You can see them in the background. We have cirrostratus, again, cirro plus stratus, so they're like thinner sheets. And cirrocumulus, cirro plus cumulus clouds. And we also have some bigger clouds that occupy like numerous levels in the troposphere. For example, we have the cumulonimbus, which you can see in the background in this image here. They're usually really tall. They have like this anvil shape at the top that we'll see a bit more later. And they usually signify heavy precipitation and thunderstorms, which we will also see later. Next, let's talk about pressure. So if you've taken any physics classes, maybe, I don't know, pressure is defined as force divided by like the amount of force exerted on some amount of area. So in terms of atmospheric pressure, that's the force exerted by the gravity of an air in a column. So as you can see over on this, over on the right, you have like this massive column of air that goes high into the atmosphere. So when you're like really high up, there's not much air above you, so there's no force of gravity. Therefore, the pressure at the top is around zero, or zero psi. Psi means pounds per square inch. And on the bottom, you have an entire 310 miles of a column of air above you. So there's going to be some weight, and therefore the pressure comes to be around 14.7 pounds per square inch. And yeah, there's numerous numerous units of pressure that we use: atmospheres, pascals, hectopascals, millibars, millimeters of mercury, and again, pounds per square inch. At sea level, where the altitude is zero, like at the bottom there, the pressure is 1 atmosphere, which also equals around 100,000 pascals, 1,000 millibars, 760 millimeters of mercury, and 14.7 psi. Now let's look over some tools that we use to study the atmosphere and meteorology. So first, we have what are called like in situ tools. These are like your thermometers, barometers. I think it's called anemometer. So these are usually on the, well, I'm pretty sure they're always on the surface, and they kind of measure the properties, like temperature, wind speed, pressure at the surface. Barometers. So these barometers measure pressure. So I think the prefix baro means pressure. Next, we have some instruments attached to balloons. So when they're attached to a balloon, they can ascend into the atmosphere. For example, radio zones. Yeah, like these balloons purple balloons you can see in the image. And these measure, again, like your pressure, temperature, humidity as they go up in the air. We also have radars and satellites. These tools measure properties that are far away. So for example, you can have a radar, which is over here on the right. It can shoot like some pulses up some clouds, and then read like the backscatter to try to analyze the cloud. We have satellites, which are orbiting around our Earth, and they kind of observe our atmosphere from above and give us more valuable data. And yeah, so all this data will be sent back to some, I guess, like here, the National Meteorological Service, and experts or scientists will process this data, tell us, our daily weather. Maybe there's a thunderstorm or something coming up. Yeah. So that will process all this data that are required by these variety of tools. Okay, now let's look into severe weather, which is one of the topics from the event cycle. So the main types of severe weather is we have thunderstorms, tornadoes, hurricanes, and winter storms. So over here you can see a thunderstorm. And yeah, severe weather is quite important to study because we need to stay safe from these incidents. What's the difference between tornadoes and hurricanes? We'll soon look into that, but briefly, I guess hurricanes are much larger, like much, much larger.
I think
So
hurricanes
first,
are made in water.
yeah, hurricanes are also in water, while tornadoes generally are over land, you can say. Yeah, we'll look into that a bit more pretty soon. So, but let's first talk about thunderstorms. So for aren't winter storms like blizzards? Yes, they are. Um, so the ingredients of a thunderstorm to like occur is we need to have moisture first. We also have we want to have well we don't want to have but like there will be a warm unstable rising air. This is often also called updraft or going upwards, and we need something to lift this air. So over here you can see like the structure of one. As you can see, there's this warm updraft that like goes into this cumulonimbus cloud. And thunderstorms, they become severe when you have 1 or more inches of hail. You have winds that go past 57.5 miles per hour, or a tornado occurs. Yeah, so again, you can see this updraft. You can also see this downdraft. This is where all the precipitation, maybe the hail, the rain, this is where it all comes. And the types of thunderstorms we have single cell. These are smaller and briefer storms. They're relatively weak compared to the other types. We have multi-cell. These are like more groups of cells, like thunderstorm cells. Yeah, they usually last up to hours, maybe producing hail, like strong winds, and occasionally weaker tornadoes. And then we have the last one, which is a supercell. These are huge rotating updrafts, which are also called mesocycles. And these are by far the most intense thunderstorms, and they usually have powerful tornadoes. And so for thunderstorm safety, you want to try to stay inside a sturdy building. If you're outside, try to find shelter immediately. And yeah, try to also avoid like bodies of water, open spaces. I think tornadoes and hurricanes are formed by cold air and warm air when colliding. Yeah, so this is where this unstable comes from, when these two contrasting fronts meet. Okay. Next we have tornadoes. And so tornadoes are mobile, which means they move, and they're usually destructive. And they're called vortexes, which is kind of like this funnel shape. And for tornado, we need a strong updraft. We need wind shear, which is basically varying wind speeds at different altitudes. We want moisture at the base. Again, we want this instability, which is caused by cold and warm air colliding. Yeah, we usually want a high wind speed as well. And these tornadoes mainly come from supercells. So the Great Plains are like a pretty like a nest of tornadoes, you can say, right? Because the warm, humid
Tornado Alley.
air from Tornado Alley. I think that's a more like defined term. This happens because the warmer air from like the tropics, like down south, this meets the colder and dry air from the mountains, and this leads to high instability, which causes tornadoes. And to measure the power of tornadoes, we use the enhanced Fujita scale, and this scale takes into account the damage and the winds. So over on this top right, you can see the scale ranging from 0 to 5, 5 being the strongest. And some signs of a tornado, there's not many here, but I mean, if you see dark or a green colored sky, maybe a dark and large low-lying cloud, you see lots of hail and or some very loud sounds. sound like an approaching freight train. And for tornado safety, you want to go into the basement or a room without windows. You want to have many supplies ready, such as batteries, foods, water, radio. Radio, you can hear like news about it, and you can like hear more like warnings. Maybe they'll tell you when to evacuate, stuff like that. If you're in a car, well, you want to stay in the car. Don't try to like go outside and run. If you're in a car, yeah, keep your seatbelts fastened, cover your head, try to find, shelter for your car. And if you can't find any, try to find lower areas and make sure you don't leave your car. Next, let's look at hurricanes. Hurricanes are cyclones that form over the ocean, but these are much larger than your general thunderstorms or tornadoes. The ingredients, we need warm water, usually greater than 26.5 degrees Celsius, and we need a low vertical wind shear, meaning the wind speed is relatively constant at different altitudes. So the structure of the hurricane you can see here, we have the eye in the middle. This is the center of a hurricane, and it's actually really calm in the middle of the eye. And then we have the eye wall around it, and this is the most devastating region. We have high rain and high windfall. And then we have the rain bands, which are like lots of larger clouds that they spiral out from the eye wall and give us lots of rain. Yeah, I think this image is wrong. The storm rotation should be counterclockwise, I believe. But anyways, the hazards of hurricanes, we have storm surge. This is basically coastal flooding. This is the greatest hazard from hurricanes. And of course, we have high winds and heavy rainfall again. And yeah, over here you can see the scale to measure hurricane intensity, the Saffir-Simpson scale, and I'm sure you've all heard of like the Category 5 or Category 4 hurricanes that usually occur late in fall. And safety, you should plan where to go, have an emergency kit again. If you're like within a tornado within a hurricane, try not to go outside, take cover in an interior room and avoid windows. And again, have a radio so you know when to evacuate immediately.
In a hurricane, the eye is the most calm. So if the hurricane seems like it's over, you shouldn't go out immediately, because then the other side of the eye might hit.
Yeah, and again, although the eye is really calm, the hurricanes, they travel really quickly, so you can't like run in the middle of the eye the entire time.
If you think it's fine, you should still check.
Yeah, but like it will like the eye will like since the hurricane is moving, so the eye will eventually like leave, and then you'll be in eye walls.
If you're outside, you're gonna be in trouble.
Yeah. How big is the eye? One sec, let me answer this. I don't remember off the top of my head, but I mean it's probably like a couple miles radius, maybe probably a bit smaller, but I don't know, you can search it.
I guess you could go.
Yeah, you can.
I guess you could go outside in the eye for about a 1 or 2 seconds, and then just look around to see if there's anything coming in, so you could decide if the the hurricane's going to hit your spot again.
Yeah, I mean, I guess you can do that, but it's better to just stay inside and
you could also
be safe and be sure.
You could also just look outside the window.
Yeah, again, but you want to try to avoid windows because they can normally break, and you don't want
Or
shattered.
use the radio and listen to the news and see if they say.
Yeah, then Yeah, that should be the most safe option, the most like yeah, safe option. All right. Next, let's look at some satellite and radar imagery. So over here we have some images of tornadoes slash thunderstorms and a hurricane captured by radar imagery on the left and satellite imagery on the right. So um, let's begin with the bottom right. This is captured by satellite, and um, yeah, it's a hurricane. You can see by like this giant rotating um, winds and clouds, I guess. And yeah, they're in the Gulf region of, or Gulf of Mexico region in the United States, which is where most hurricanes occur because they need moisture. Right? It looks like the hurricane is bending the land. Yeah, it kind of does. Again, this could just be from like the natural curve of um the Earth when the satellite from above is taking photographs of it. On the left, we have radar imagery. On the top left, we have a thunderstorm, and there's this pretty, I guess, intriguing shape of it. We have like this hook at the end. This is called the hook echo, and this is where um, the tornado is. On the bottom right, you have another hurricane. I don't think it's the same. Maybe it is, but yeah, we don't have much time left. I'll go over winter storms very quickly. The winter storms, um, storms in the winter, I guess. You want cold air, moisture, and lift. You have blizzards, ice storms. You have this lake effect snow is something interesting. You can read over the description.
I have a
Winter
question.
storms are, yeah.
How do the hazards include carbon monoxide poisoning when it's like cold? It's like snow, sleet, or freezing rain.
Yeah, so carbon monoxide poisoning that usually comes from like I guess machines or appliances that use gas. And when this like appliance fails because of the cold weather, it releases the toxic carbon monoxide. And yeah, so you can have car accidents because of the low visibility, hypothermia, which is because it's really cold, heart attacks. Why will you? Well, generally in extreme um, scenarios, like either really cold or really hot, your body doesn't react too well to that. So you'll kind of get shocked and you might have a heart attack. And safety, try to stay indoors, prepare food, clothing, and water. But in California, you'll probably won't experience this. Winter precipitation, we have three main types. We have snow. This is precipitation that falls. It's called snow as long as the temperature is always below zero, so it's always freezing. We have sleet, rain. Okay, I don't know what that means, but sleet, we have these snowflakes that partially melt through this shallow warm layer over here. And this warm layer is greater than 0 degrees Celsius, so it will melt. And then we have freezing rain. This snowflakes they melt through like a bigger warm layer, so they like completely melt and then they refreeze as they partially refreeze as they enter a cold shallow layer. What about hail? Um, I don't think that's like a one of the types of winter precipitation. You can still see hail when it's not like a winter storm. Okay, and well, it's 5:30, but I do have a Kahoot. So I guess you can leave if you have to leave, but if not, you can stay for the Kahoot. I think Andrew will share screen for the Kahoot if he's still here. Yeah, and if you have to leave, goodbye, everybody. I hope you learned something either from Dynamics Planet or Meteorology. And yeah, see you guys tomorrow. Yep, so here's the Kahoot if you want to join. Hopefully it doesn't take too long. Yeah, I think that should be enough to start for now. 20 people. 21.
Can I start?
Yeah, I think you can start.
Right.
In which layer does most of the weather phenomena occur? And yeah, feel free to leave again if you have to leave. Yep, the troposphere. This is the layer that's closest to the surface of the Earth. So it makes sense, I guess. What is Earth's atmosphere primarily made of? Which, well, I guess, element or molecule? Yeah, so nitrogen. Remember, nitrogen is around 78 or 77%, while oxygen is 20-ish percent.
You would not want the atmosphere to be mostly hydrogen. Most of it would just burn up immediately. And then you get the Hindenburg 10.0.
Yeah. Which atmospheric cell is found at the most northern/southern latitudes? Yep, we have polar. I guess you can tell by most southern/most northern, so nearest to the poles. Which best describes a nimbus cloud? Yep, rain. Again, nimbus, I think it means rainstorm and flat. What is the sea level pressure in millimeters of mercury? And this one's a pretty memorization based, but if you see it a lot, it shouldn't be too hard to remember.
This is useful in AP Chem, or at least, or many chemistry classes when we're talking about gases.
Yeah. Yep, so we have 760 millimeters of mercury. Which of these conditions in thunderstorm is severe? Yeah, so it's hail. So remember the conditions are something like there should be a tornado, or there's over an inch of hail, or the wind speed is over 57.5 miles per hour. So yeah, only 1.5 inches. What is the most common scale that we use to measure tornado intensity? Yep, the E Fujita or the S Fujita. What is the most common scale for hurricane intensity? Yeah, this one says Saffir-Simpson scale. What type of winter precipitation does this picture depict? I think I went through this pretty quickly, but so we have a shallow, warm layer, so partially melts and then it completely refreezes back in the deep, cold layer. Yeah, so this is sleet. For it to be freezing rain, we want like a deeper column of warm air in the middle. So yeah. What does the curved shape on the bottom represent? On the bottom left. Remember that this is our hook echo. Yep, it's a tornado. Which of these locations of the house is safest during a tornado? Yep, the basement. What is the greatest hazard of a hurricane? Storm surge, which is coastal flooding. Which of these best describes the hazards of a winter storm? Low visibility and hypothermia. Yeah, hypothermia is caused by extreme cold conditions. Which object is generally used to describe the shape of a cumulonimbus cloud? Yep, we have an anvil. Last question. What type of cloud is this picture? Yep, these are cirrus clouds with the wisps. So let's see the results. Good job, Mia. Good job, David. And good job, Acai Apple. Nice. Yeah, I hope meteorology wasn't too difficult. Hopefully it was relatively simple or straightforward. But yeah, if it wasn't, that's nothing to be ashamed about. And I think this concludes the end of this class. You guys are free to leave and see you guys tomorrow.